Hi everyone, good evening. We just had a little glitch, but it's all sorted now. So, very warm welcome to this lovely class that we are about to have on redox reactions. Let's see who all have joined in for the session. So, we have Rudra here, Vivek, Nagendra, Yashwant, Ruchika. Good evening, guys. Ragvi, amazing artist. Who's this amazing artist? Sajit, Ruchika, Binila, Yash, all of you've joined in. Awesome. So yes, today we will be covering a really important topic, that is redox reactions. I think this is the most interesting topic from this chapter, chemical reactions and equations. Do you also feel the same? Have you heard about this term anywhere? I'm sure by the end of this class you'll be able to answer with a big yes that yes, this topic was very interesting. But have you heard about this term? Let's see. Meanwhile, let's do one thing. Let's have the chat over here as well. Yes, I see a lot of you making guesses and all these random guesses are actually right. Hey Vivek. Hey Ashi. So yes, we'll be talking about this very important topic, and you know this topic is so important that there is a high probability कि आपको इससे question जरूर आएगा exam में. There's a high probability that you will be getting a question from this topic for sure in one of the sets for sure. Hey Naina. Alright, so before we dive straight into it, this is something that we have for you. You've seen our commitment. You've seen that it's actually our mission to make sure that you excel in the exam. And we keep coming up with amazing sessions for all of you, different kinds of sessions to make sure that your learning is actually, it's like a progressive graph that we have, right? So we are super confident this is the best app for you. Byju's app is definitely, without a doubt, the best app for you. You download it and you will check for yourselves. It has all the amazing classes also. And where is the link? The link is right there in the description box for various packages. So you can check that out too. Plus, of course, you can attend the live session of any of the topic from any of the chapter of your choice and of course at your convenience. Yes. So yes, I would definitely recommend that you should go for it. Try this out. Hey Joshna, Manasa. Manas. All right. Yes. I can see Joshna is here. Manas is here. Yes. Good evening, all of you. Arush. A lot of you have joined in. Awesome. So, you know the drill. We'll be starting with the homework question. But before that, you have to give me loads and loads of thumbs up, loads and loads of smileys to let me know that everything is working fine. If you can hear me properly, see me properly, quickly, you can let me know. Perfectly audible or not, perfectly visible or not. Great, Sajid has already given me 2 thumbs up. Waiting for all of you. Vivek, Binila, Sunena, Ashi, thank you for giving me a good to go. So let's get started with the homework question first. Now the question was, which among the following is or are double displacement reaction? So what you had to do was you had to look for the exchange of ions that is taking place, right? So you've got 4 cases over here. You had to check the exchange of ions. Now this question was being done by Nabosha, amazing artist. And she's here also with us. Lakshmi, Debashish, Muskan, Amalu, Ragvi. Ragvi is also here. Arush, Tavishi, Mahamaya, Science Fly, Preeti, Mayank, Lakshit and Ashi. So well done guys. I am getting the same names, mostly the same names every time. And this shows your sincerity. Great, and I can see a lot of you posting the answer now as well. Correct, yes. So, yes, you people are right. You people are landing on the correct answer. So, without further ado, I'll let you know what the correct answer is. In option B, you can see that you've got sodium sulfate and barium chloride. They are exchanging their ions to give you, first of all, this is a precipitation reaction also that's happening, right? Because we are getting a wide precipitate of barium sulfate and of course sodium chloride. So the correct answer is only the second equation, that is this. Here we can see the exchange of ions. So we've mastered all the types, right? There's another really important type that we will be covering today. So today we will be talking about oxidation and reduction reactions. And when we were, starting with this class, I asked you, have you heard about this term redox? And I saw a lot of you were writing about oxidation and reduction reactions. So yes, you can actually figure out what redox means, right? Then we would also be talking about corrosion and rancidity. Again, two very important topics from this chapter. And your favorite bit, that's the homework question, would also be there towards the end. Yes. I see a lot of you write yes. Alright, so first of all, I want you to observe the reaction that I'm just about to show you right here. Let's say we have a china dish containing some copper powder. So you can see there's a china dish and it's containing copper. Let's heat this. So we have a burner also with us and observe what is happening. So tell me, what do you see? What's the change that you can see? What about the surface of copper powder? Is it the same? Is it becoming a bit different? She's saying change in color is happening. Pinila is saying some black coating is coming up. Different for sure. Copper oxide. Yes, definitely. What you can see is that there is copper oxide that is being formed, and this copper is actually turning black in color. Now, why is it turning black in color? So, copper is reacting with oxygen to form copper oxide, as you people are already mentioning over here. And yes, that is black in color. So, over here, this is the formation of a new substance that is being formed. Right, so copper was brownish in color, but copper oxide is black in color, and this is the equation for the same. So you've got copper reacting with oxygen, in a way heating in the presence of oxygen, right, to give you black colored copper oxide. So very clearly this color change can be observed. You can also balance this equation, right? You just have to write a 2 here and a 2 here, and this equation is now completely balanced. Yes? So I can see Arush is constantly mentioning, and Vivek is saying the same thing, कि ma'am oxidation हुई है यहाँ पे, oxidation is taking place. Copper reacting with oxygen to give you copper oxide. Clearly, what we can see is that there is a gain of oxygen that is happening, and we are calling it oxidation. So this brings us to the very first important definition of oxidation, that is addition of oxygen or removal of hydrogen. या तो ऑक्सीजन ऐड होगा या हाइड्रोजन आपका रिमूव होगा. अगर ये हो रहा है then that process is oxidation. So oxidation is the addition of oxygen or removal of hydrogen. Yes, Ragvi. Yes, Ashi. Correct. Let's do one thing. Now, let's try to pass hydrogen gas through it, okay? So, if hydrogen gas is being passed through this heated material, as you can see over here, this heated material, by the way, is copper oxide now. This black colored coating is in a way changing to brown again. So, reverse reaction is taking place here. Right? Why do you think this black colored copper oxide is turning brown again? Yes, Avan, we'll definitely come to that. Reduction, okay. Copper is being formed again. Reduction. Arush is amazing artist. Reduction. Alright, yes. So, you people are already on the right path. Copper is basically obtained back, right? And we know the color of copper, right? So, When copper oxide reacts with hydrogen gas, what do you get back? You get back copper, and this is going to be the equation for the same. Copper oxide plus hydrogen, if you continue heating it, copper plus H2O. So yes, everybody who's mentioning H2O, you people are right. Great. So over here, what did we notice? All of you have already mentioned this. CuO, that's copper oxide, is turning into Cu. What are we observing? That oxygen is getting removed. Oxygen is getting lost. There is removal of oxygen, and this is reduction taking place. So, just like oxidation, let's understand what is reduction. It's the addition of hydrogen and removal of oxygen. हाइड्रोजन का ऐड होना या फिर ऑक्सीजन का रिमूव होना, इसे हम क्या कहते हैं? We call it as reduction. Hey Miss Tarkar, if you're talking about redox, then yes. But not always. There are various other ways also. In terms of electrons also this can take place. We'll discuss about all this, don't worry. Yes, electronegative species also. Alright, so this is the equation that we have, right? Let's discuss about this a bit more. I think a lot of things, a lot of important points are hidden in this. Yes? So let's talk about this one. Alright, so over here you see that H2 is getting converted to H2O, correct? And we discussed this, that oxidation, over here you see oxygen is being added, right? So oxidation, you all know by now, oxidation is taking place because oxygen add ho raha hai, gain ho raha hai. CO to Cu, in this what you can observe is that oxygen is getting removed. There's lots of oxygen, and this is reduction. But hey, oxidation and reduction both are happening over here, right? And such reactions are basically known as redox reactions, where oxidation and reduction, so you can have a look over here, reduction and oxidation, they're taking place simultaneously. So that's why we call them as redox reactions. I hope you'll always remember this. Yes, this is a redox reaction. Awesome. Yes, absolutely right. Correct. Now, let's learn some more terms. We know what oxidation is, we know what reduction is. Let's get to know about oxidizing agent now. When we talk about oxidizing agent, it's a substance that oxidizes others. So it's going to oxidize others, and itself it will get reduced. When we talk about reducing agents, it is going to reduce others and itself get oxidized. Okay, let that sink in. A lot of information in last 5 minutes, right? Oxidizing agent it's like an agent which is oxidizing others. So if it's oxidizing others, itself it will get reduced, right? Reducing agent, it's an agent that is reducing others. If it's reducing others, itself it will get oxidized. No, I'm not ignoring anyone. Great! Vivek says yes, we've understood. Awesome. Alright, so in this redox reaction, let's discuss some examples over here. Okay, to make sure that you've understood. Yes, opposite, correct. Yes, Amulu. Yes, Raghavi. We've got H2S plus Cl2 giving you HCl plus S. Okay, now from H2S to S, what is happening? You can see that hydrogen is getting removed. This loss of hydrogen, and we know what is loss of hydrogen, that is oxidation. Similarly, you can see from Cl2 you're getting HCl. Hydrogen kya ho raha hai? Hydrogen is getting added, right? Gain of hydrogen is taking place, so that is reduction. So if I say which substance is getting oxidized, you would know that this is the substance that is getting oxidized. I'm writing over here. If I ask you which substance is getting reduced, you would know that this is the substance. Cl2 is getting reduced. Sorted till here? Now the first important point is that whenever you have to look for the substance that is oxidized or the substance that is reduced, or oxidizing agent or reducing agent, you just have to look at the reactant side. Don't look at the product side. From the reactants only we'll choose. So you've got H2S as the substance that is getting oxidized and Cl2 as the substance that is getting reduced. Now, the reducing agent will be just the opposite. So the substance getting oxidized will actually be your reducing agent, that's H2S. And your oxidizing agent will be the substance that is reduced, that is Cl2. So, I'll repeat this once again because I know for the first time when we understand redox, it's a bit heavy. This is going to be really simple if you just remember just 2-3 points that I'm telling you. First of all, you just have to look at the reactant side. For the substance oxidized, for the substance reduced, oxidizing agent, reducing agent, you're just concerned about the reactants. Forget the products. Your answer will be there in the reactant side only. Now, just figure out which is the substance that is getting oxidized. The moment you identify which substance is getting oxidized, then that substance will also be the reducing agent. Just identify the substance that is getting reduced, that is going to be the oxidizing agent. So, in a way, you just have to figure out one thing. Great, I see a lot of you right about it. You've understood it. Awesome. Yes, correct. Understood. A lot of you. Quick thumbs up if you've understood this. Then we'll quickly go through some more examples. Sajid, Ragvi, Vivek, Muskan, everyone's understood this. Great. Alright, so let's move on. We've got another example. Now, can you tell me which is the substance getting reduced? Quickly tell me which is the substance that is getting reduced. I'll ask you so that you're able to participate and answer in a better way. Clearly understood. Alright. Quickly, if you've understood, tell me which is the substance that is getting reduced. Arush has already answered MnO2, correct. So, MnO2 is in a way undergoing reduction. This is the substance that is getting reduced. Which is the substance that is getting oxidized? Which substance is getting oxidized? If it's getting oxidized, you have to check. Is it gaining oxygen or removal of hydrogen is taking place? Let's see. Vivek is the first one to answer about HCl. So HCl is undergoing oxidation. So HCl is in a way getting oxidized. So MnO2 is getting reduced. It's undergoing reduction. HCl is getting oxidized. It's undergoing oxidation. All set for the next example? Quick thumbs up and then we move on to the next example. Let's see who will answer this first. Because I see a lot of you saying yes, we've understood. But I want to check if you've actually understood. Great. So let's check this one. Alright. So we've got lead oxide. We've got PbO plus C giving you Pb plus CO2. Come on, tell me now this one. Which is the substance that is getting reduced according to you? Which substance is getting reduced? Quickly let me know. Hey, this time Muskan is the first one to answer. Hey Benila, it will never be Pb because Pb is on the product side. Whatever our answer would be from the reactant side. So out of these two only you have to tell. You can forget the product side. That is like a quick trick for you, that whatever I'm asking, you just have to look at the reactant side only. Yes, all of you are mentioning the correct answer. It's PbO. So lead oxide getting converted to lead. That is reduction taking place. Why? Because oxygen is getting removed. And of course, you have already figured out, Muskan ne pehle answer post kar diya, that over here you can see carbon is getting oxidized. Oxygen is being added. It's forming CO2. Great, awesome. Good to read all the right answers. And let's do one thing. Now let's observe the reaction of burning of magnesium ribbon. So let's quickly switch screens now. Let's quickly switch screens and see what's going to happen. Give me loads of thumbs up in the chat box if you're ready to see an amazing experiment happening in front of you. So give me quick thumbs up if you can see the screen. Yes, I'll just move it a bit so that you all can see it. Let's see what do we have here. We've got tongs. You can see tongs. something like scissors you can see, but it's not actually scissors. We call it as tongs. Then you can see that there is a magnesium ribbon that is being placed. Right, beautiful magnesium ribbon that is being placed, and then you see a burner also. See, there's a Bunsen burner also. What are we going to do? Hey Muskan, awesome. So she's saying a combination reaction is taking place. Good to see that people are applying all the previous information as well. But my question will be slightly different. But hey, as you're saying, let's burn. So let's see what happens when we burn magnesium ribbon in the presence of oxygen. So you all can see this, right? Great. Now, over here, note the beautiful color of, this dazzling flame that you see. There's a white dazzling flame, right? And now you can also see this white powder that is being formed. Correct. Yes, bright light, white dazzling light was there. And yes, white magnesium oxide is being formed. Alright, you can see that. You can't see the flame now, but you can definitely see MgO that is being formed. Let's go back to the main screen. And let's do one thing. I'll ask you a question that I want to ask here. Let's see. I told you to observe this reaction, right? You all have observed this reaction. Now, let me ask you, can you tell me, is magnesium in this reaction, is it getting oxidized or reduced? I see a lot of you write about combination reaction, which actually makes me really happy that you are, in a way, categorizing it as a combination reaction, which is perfectly right. But my question, I told you, is a bit different. Is it getting oxidized or is it getting reduced? Vanilla ने फटाफट से आंसर दे दिया. Now I can see a lot of you are mentioning the correct answer. Everybody is saying oxidized, oxidized, oxidized. Correct. Yes, you people are absolutely right. So magnesium ribbon is burning in the presence of oxygen to form magnesium oxide. This is the equation for the same, and clearly you can see that magnesium is in a way gaining oxygen. Addition of oxygen is taking place. So without a shadow of doubt, as you people are mentioning, the process is oxidation. Okay, this you could answer. Recall another really important reaction that we've discussed. We've talked about respiration also, right? So here what happens? Glucose is, combining with oxygen in the cells of our body, right? And it's providing energy. In a way, I have just recall the definition of respiration for all of you. It's a process in which glucose combining with oxygen and it's giving out a lot of energy. Yes? And of course CO2, H2O, yes, correct. If you've understood this respiration reaction, let me again ask you a question. All set to answer this one? Okay, so the question is, and you've got 60 seconds to answer. The process of respiration is an oxidation reaction which is endothermic, a reduction reaction which is exothermic, a combination reaction which is endothermic, or an oxidation reaction which is exothermic. Read all the 4 options because there are 2 things that you're finding out. First of all, the type. Oxidation, reduction, combination, figure that out. Second is if it's exothermic or endothermic. A lot of things are needed over here. Which option are you voting for? I see a lot of you are voting for the same option. Unanimous answer आ रहा है, बहुत ही बढ़िया. Correct. Everybody is voting for the same option. Last 10 seconds left. If you've not tried this out, quickly post your answer. At the most, galat ho jayega, but that's okay, right? We can always discuss what the correct answer is. But at least get in this habit of participating. Alright, time's up, and as you people said, it's option D. Let's figure out why it's option D now. Alright, so in this, what is happening? Glucose is actually getting oxidized and it's producing CO2 and H2O, right? You can see this over here, and a lot of energy is also given out. Yes? Now, During respiration, if oxygen is in a way it's gained, we are calling it oxidation, and heat energy would come here. A lot of energy is being released. So of course, if energy is being released, you would know that this is exothermic. So the correct answer would be an oxidation reaction, which is exothermic, option D. And since all of you landed on the correct answer, okay, this is not a very good smiley. I'll make it again because yes, I'm really happy that all of you landed on the correct answer. Better than the last one. Okay, so yes, this is going to be the correct answer. Cool, alright. Now tell me another thing. Can you name some redox reactions that you observe in your daily life? Or oxidation reactions? Yes, oxidation reaction would also do. Okay, let me show you something and I'm sure you'll be able to identify. Over here, we have an iron object with us. Okay. Now, can you notice some reddish brown deposits over there? What is it? Hey, Suresh. Suresh, Ramesh, Binila, Vivek is already answered. You can identify the process for sure. Yeah, I can see that. A lot of you are mentioning the same thing. Yes, correct. The process is actually rusting that is taking place. Now, whenever there's an iron object that is present in damped air, what's going to happen? If it's in damped air for a considerable amount of time, it gets covered like this, with a red, brown, flaky substance that you can see on the screen. And this is called rusting of iron. Now for other metals also, we use a general term. We use a term that is corrosion. In case of iron, we say rusting. So iron has corroded, but that's a special name that we've given to it, that is rusting. In general, for other metals, you can call it as corrosion. So when a metal is attacked by a substance around it, such as moisture is there, acid, it is said to corrode. It is said to degrade, and that is known as corrosion. Good. Alright, now since you people are super duper awesome today in observing, tell me about this one. Can you guess the original color of Statue of Liberty? Let's see who will answer this the first. Who's going to be the first person to answer this one? Because today you people are really active. You people are really, the chat box is just flooding with answers. Original color, first or second one? A lot of you are voting for brown. Everybody is voting for brown. Yeah, so I can see a lot of you are saying initially the color was brown. Correct. Alright. Yes. So, initially the color was different. Now after corrosion of copper, the color has definitely changed, right? So copper particles are actually undergoing corrosion and they are reacting with oxygen, they are reacting with moisture, with carbon dioxide, and they're developing a greenish layer, that you can see over here on the surface. This green coating is nothing but basic copper carbonate. So initially, yes, brown, but later on some greenish coating is coming up. Yeah, correct. Okay, something else also that you must have observed, I'm sure. What about silver coins? After some time, you see that the color changes, right? Have you noticed this? All these examples are something that you can completely relate to your day-to-day life. Have you noticed this one? Yes, corrosion is taking place. Yes, Arush, silver. What is happening to this? Is it also getting corroded? Hey, a lot of you have noticed this. Awesome. So yes, you people are right in this case also. This tarnishing of silver that is happening, right? And it's leaving the surface black. So we've got silver that's reacting with hydrogen sulfide, that's H2S, and giving you silver sulfide and of course hydrogen. So this silver sulfide is what is black in color. Yes, tarnishing is taking place. Silver corrosion, all right. Yes, sulfur in the atmosphere can also cause it. Great. Awesome. All right. Now we've understood about corrosion. This is another really important that we have to understand. Since we're talking about oxidation so much, have you ever noticed this? Imagine something that you really like to eat that contains fats and oil. On day one, you'll be like a like a foodie, I would say, who would definitely want to have that. But the same food item you would not want to have after, like, say, 20 days or so. What is changing over here? Yes, Ashi, correct. Everybody is saying rancidity ho rahi hai. Getting spoiled, getting spoiled. Yes, so when the food is being left in open, the food that contains fats and oils, yes, it's undergoing aerial oxidation. And due to this, there is a change in the smell, there's a change in the taste, and that foul smell and taste is because of this. Yes, absolutely right. And by the way, it's going to be unfit for consumption after some days, right? So yes, that's a big no-no for all of you. Correct. The process is rancidity. Good to see that you people are participating so much today. So when fats and oils are, they are in the open for long, they get oxidized. So oxidation is not always something favorable, as you can see over here. And they become rancid, and the smell and the taste is changing, and this process is rancidity. Smell is too bad after some days, Ashi says, and I agree with her completely. Yes, color can also change actually. Yes, smell also changes. Hey, Arush is mentioning something about nitrogen, so let's pick that up. So, have you ever noticed that the chips, the packet of chips that we eat, and we all have, had this at some point or the other, it's actually containing nitrogen gas. But why? Yes, Muskan, color change also, taste change also. Okay, coming to this point, why? Why is this happening? What do you think? Antioxidants. Miss Tarkar, alright, to prevent oxidation. Antioxidant. Yes, correct. So they're being flushed with nitrogen. See, chips contain fats and oil, right? Now the packet is being flushed with nitrogen because that's an antioxidant. Nitrogen is inert. It is unreactive. So it can prevent rancidity. Bilkul sahi. Alright, so if you've understood everything that we've discussed, I have a question for you. I'll keep, shooting questions in between because I want to check if how attentive are you in the class. The question is this. Identify the substance that is being reduced in the equation given below. Reduced. You've given me loads of thumbs up that we've understood everything, so solve this question. CO2 plus H2 giving you CO plus H2O, which is the substance that is getting reduced. Reduce ho raha hai, matlab? What is happening? Loss of oxygen or gain of hydrogen. That's all that you have to check. For everyone who's saying C is not there in the option, C is not there in the equation also. I told you one thing, you just have to pick up basically one of the reactants. So the answer is either CO2 or H2. I've given you the hint also. So you can mark this as wrong and this also wrong because carbon monoxide, that's CO and H2O. It's on the product side, right? So definitely these two are not the answers. Only the reactant side. Remember this, guys. This is like a quick trick to figure this out. You just have to see the reactant side. Now I can see everybody's landing on the correct answer. So let's discuss this. So CO2 is in a way losing oxygen. It's getting reduced. So you know which substance is getting reduced, right? And H2 is of course gaining oxygen. It's the substance that's oxidized. Oxidation is taking place. So the correct answer is option A, CO2. Awesome! So good to see that you have solved this. For some reason you were mentioning carbon. I hope that doubt is absolutely clear. If yes, first of all, quickly like this video and give me loads of thumbs up over here. Let's see how many of you are super confident about redox reactions. Great. Good to see that. Alright, so let's move on to the homework question now. In the following reaction, between lead sulfide and hydrogen peroxide, you have to identify the substance that are oxidized and reduced respectively. And you can leave your answers in the comment section below right after this live class. And yes, you can join us on Telegram as well. I hope all of you are there. If not, quickly go ahead and connect with us on Telegram also. The link is there in the description box. You'll get everything out there. And for the ones who've joined in late, we have the link for this in the description box. You can check out various packages that are available. And yes, you'll actually be trained. You'll actually be learning from India's top teachers. And there's going to be a 2-teacher model, doubt clearing. So many amazing things are going to be there. Check this for yourself. I'm super confident you'll like it. Yes, we have to post the homework. So right after the live session, you come back and post your answer in the comment section. Alright, so yes, we've got you covered and we'll keep coming up with amazing sessions for all of you. And don't forget to like this video, subscribe to our channel and hit the bell icon so that you get notified about everything. Now it's your time to revise the entire chapter. Yes? So have a good revision of the chapter and then of course we'll be back with amazing session for all of you. Alright guys, so keep exploring the magic of chemistry and I'll see you in the next session. Take care, bye-bye.